Boom! Alright, so welcome to this video in our series as we continue to deal with the topic of number bases. In the previous video, we took a random number, the number 75 to base 10, and we expressed it to base 5, we expressed it to base 4, we expressed it to base 3, and we expressed it to base 2. So in other words, we took the number 75 and we expressed the same number in 4 different bases, just to make the point that we could transform any number in base 10 to any base that we choose. So in this video, I'm going to do the process in reverse. I'm going to take these same 4 numbers, alright, in bases 2, 3, 4, and 5, and convert them back to base 10 and verify that in each and every case we will get the same answer, 75. So I'm going to do that to demonstrate the process, the procedure. And of course, for those in my paid platform, you will then have an exercise to practice, just as we did in the previous video. So we get in practice in transforming from base 10 to other bases, and we're going to go the other way now and practice changing from other bases to base 10. And then after that, we'll have some mixed exercises, mixed questions, where we mix up the direction. All right, some of the questions will be base 10 to other bases, some of the questions will be other bases to base 10. All right, so let us start with base 2. So when we had transformed 75 to base 2, we had gotten 1 0 0 1 0 1 1 to base 2. So in other words, if you have this as a question, if they give you this and they tell you express that as base 10, what do we do? Remember, of course, the whole concept of the sum of powers. So if we have a number already in base 2, what we have to remember is that that is a number that is expressed as the sum of powers of 2. And of course, because we in base 2, the digits will only be 0 and 1. So in other words, none of these digits here will pass the number, will be greater than 2. In fact, it wouldn't even be equal to 2. All the digits will be less than 2. And that is the same logic we will apply for all the other bases. So 1 0 1 0 1 1 in base 2, we do a little table and we look at these numbers here. So we have the number 1 1 0 1 0 0 1. All right, of course this will be 2 to the power of 0, this will be 2 to the power of 1, this will be 2 to the power of 2, this will be 2 to the power of 3, this will be 2 to the power of 4, this will be 2 to the power of 5, and this will be 2 to the power of 6. All right, we could separate them like this as well if we want. So this number will be written then as follows. This will be 1 by 2. Well, I'm going to start with the highest power just to keep it consistent, right? We already have the number written out here, so we know what it means. So this is 1 by 2 to the power 6 plus, and we're going to write the whole thing out just for emphasis, 0 by 2 to the power 5 plus 0 by 2 to the power 4 plus 1 by 2 to the power of 3 plus 0 by 2 to the power of 2 plus 1 by 2 to the power of 1 plus 1 by 2 to the power of 0. Right? That is essentially what that number signifies. And from here now, I'm going to rub off everything else on top just so we could complete the write-up. Alright? So, going back on top now, we will now have that being equal to 1 by 2 to the power 6 is 1 by 64. We take out these for simplicity, 0, 0, and 0. Plus 1 by 2 to the power of 3. Sorry. 2 to the power of 3 is 8 plus 1 by 2 to the power of 1 to the power of 1 plus 1 by 2 to the power of 0. 1 by 2 to the power of 0. Which is 1 by 64 is still 64. Plus 8 is still 8. 1 by 8 is still 8. Plus 1 by 2 is still 2. And 1 by 2 to the power of 0 is 1. So that'll be 1. And look at right there. 64 plus 8 is 72. 72 plus 2 plus 1 is 3. 72 plus 3 is 75. So that is the first one that we're working backwards, where we had the base 2 equivalent, the binary equivalent of 75. We started with that and we made the conversion to go back to base 10, and we verified that in fact we actually get 75 as the answer. So now let us go to base 3. So in base 3 we know that 75 in base 3 is 2210. So 2210 base 3. So if we start out with that and they ask us to write that as base 10, right, we require now to convert that to base 10. So again, we do the same thing that we did the last time. We drop the little table and we proceed as follows. So this would be what? 0, 1, 2, 2. Alright? We draw the little table there. This of course will be 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, and 3 to the power of 3. And then when we write it out, we will have as follows. This will be 2 by 3 to the power of 3, 2 by 3 to the power of 3 plus 2 by 3 to the power of 2 plus 1 by 3 to the power of 1 plus 0 by 3 to the power of 0. Alright? And if we go further now, we get 2 by 3 cubed. 3 cubed is 27 plus 2 by 3 squared is 2 multiplied by 9 plus 1 by 3 is 1 by 3 to the power of 1 is 1 by 3, and of course this we could eliminate as just being 0. Alright? And then we go to the top now and we steal some room here. Let me squeeze some space on top here. So we steal some space on top here and we get 2 by 27 is still 54. Alright? Plus 2 by 9 is 18. Plus 1 by 3 is 3. Alright? So you get 54 plus 21, which is still 75. Alright? So you see the conversion of the base 3 equivalent back to the base 10. You see the process that we went through here, and we got that 2210 to base 3. When we work it back, we end up with 75 to base 10. Alright? So we're going again. We have now the equivalent base 4. The base 4 equivalent of 75. Alright? The base 4 equivalent of 75, which is the base 4 equivalent of 75 is 1023. Alright? So they want us to take 1023 to base 4 and express it to base 10. So when we get this to base 4, we do the same thing that we did in the previous two cases. Alright? So we have we go up in the corner here now to maximize the space. Alright? 1, 0, 2, 3. Boom, bam, bam. So this will be again 4 to the power of 0, 4 to the power of 1, 4 to the power of 2, 4 to the power of 3. Alright, so when we write this number out, what we will get would be 1 by 4 to the power of 3 plus 0 by 4 to the power of 2 plus 2 by 4 to the power of 1 plus 3 by 4 to the power of 0. And then we go in again. 1 by 4 to the power of 3 is 1 by 64 plus, well, let's just be 0. We could write the 0 just for emphasis if we want. 2 by 4. Here, 2 by 4 to the 1 is 2 by 4 plus 3 by 4 to the 0 is 3 multiplied by 1. Yeah? And we're switching the colors up now. And this will give us on this side 1 by 64 is 64 plus this 0 will be out. 2 by 4 is 8 plus 3. So 64 plus 11 is 75. The same 75 that we had when we started. So you see the conversion of the base 4 equivalent back to base 10, and we get the same 75. So we're going to do the same thing now for base 5. So in base 5, the 75 in base 5, hold on, let me rub this off in totality here now. Excuse. In base 5, the 75 was 300. So 300 to base 5. And we want to convert that back to base 10. Alright, so again, we go 300. Alright, this is 5 to the power of 0, 5 to the power of 1, 5 to the power of 2. So in writing this out, we have 3 by 5 squared plus 0 by 5 to the power of 1 plus 0 by 5 to the power of 0, which is 3 by 25 plus 0 by 5 plus 0 by 1. Let's write it out just for emphasis there. Which we come across here and we switch up the colors now. And we will get that that is equal to 3 by 25 is just 75. Of course, this and this will be 0. And look it right there, 75. Alright, so that was as simple and as straightforward as it is. Alright, but to get to the point where you can run through this, you have to go through everything from before, where we start with the familiar, which is base 10. We understand that in base 10 we express all numbers as the sum of powers of 10. We take that same essential idea and apply it to any base. So base 9 will be the sum of powers of 9. Base 11 will be the sum of powers of 11. Base anything will be the sum of the powers of whatever that anything is. And once you understand that core idea, you're now in a position where you could change from base 10 to other bases. And we took our time and we went through the process for that in the videos prior to this one. And that now would take us to this point where we could switch back from other bases back to base 10. Alright, so that basically is it as far as the fundamentals of number bases are concerned. At this level is not the place for me to go into addition of, let me say, adding in base 5 and adding in base 3 and all that, right? That is not something that I plan to teach in any great detail, at least now. And if you ask me personally, I don't really think it that necessary. I mean, what's the point of somebody knowing how to add in base 3, right? What you need to know though, and I think is very important, is one, to understand the basic concepts so that in later applications, when you start to deal with other number bases, whether it's binary or base 8 or base 16 or base 60, strangely enough, we tell time in base 60 here, the fact that we have 60 minutes, 60 seconds in 1 minute, and then 60 minutes in 1 hour, right? So basically we count in base 60 when we're talking with time, but it is an underlying concept. It is not in your face then, so to speak. So this is about just understanding the basics, the fundamentals. All right, the ability to switch from base 10 to any other base, and the ability to switch from any other base to base 10. That is what you need. Anything else could come after, depending on if you're in a more specialized environment. All right, so for example, if you're working in some kind of digital environment, you might actually need to develop the skills of adding in base 2, multiplying in base 2, division in base 2, subtraction in base 2, etc., etc. All right. In some computing environments, they deal with base 16. I think they call that the hexadecimal numbers or something like that. Maybe you might need to do arithmetic in base 16 if you're going real deep into it. Who knows? But anything short of that, fundamentals. Switching between base 10 and any other base in any direction, that is very solid, and you could do a lot of things with that. So I hope that you have enjoyed this series of videos, and I would encourage you strongly to continue. Do the exercises in the paid platform. All right, if you're not in the paid platform and you don't intend to get in the paid platform, then find some other exercises somewhere and make sure that you strengthen your ability to switch from base 10 to other bases and from other bases to base 10. All right, so take care, keep good, stay on board. As always, we have plenty more videos coming your way.